Hello everyone and welcome to our new video regarding the latest PC-3000 7.7 update. This update will bring a lot of new features and of course it will bring one of the most excited feature that will help you to work with Helium drives based on Hitachi and WD technology. My colleague Sergey will detailedly talk about this new utility. He will demonstrate you some real-life cases and he will try to explain how to work with these drives using the new update and using the new utility. I hope you will really enjoy it. As always, SATA developers are trying their best to add the most good and the most effective features into PC-3000 software. And today we also will talk about the SSD drives. We will show you how to work with the new controllers which ASLab developers add into PC-3000 system, and also we will show you the new feature that allows you to work with formatted Phison-based drives. Actually, ASLab developers already add the possibility to work with silicon motion drives, but right now the new feature is coming, and if your drive is based on Phison controller, it doesn't matter what type is it, SATA or NVMe, and this drive was formatted or it contains some deleted files, of course, with the help of new feature, it will be possible to completely recover data even from such drives which were previously not possible to deal with. And again, we support new controllers, we support new features for SSDs, and let's talk about all of this just right now. So I will pass my words to my colleague Sergey, who will in detail tell you the features that have been added into 7.7 update, and especially he will tell you more about Hitachi Helium drives.
Hi guys, Sergey is here again, and as usually, today I will tell you about new options and features which will be available in new release of PC-3000 software version 7.7. And as you probably know, the main and more important thing which is related to the HDD recovery is the new utility for CCB drives. This utility have been already announced almost 1 year ago in Maga, and right now our developers finished their work and we are ready to show you this utility, and I will demonstrate how to use it on practice. So first of all, CCB means common code based, and these drives may be different. In my right hand I have HGST drive, Hitachi drive, 6 terabytes capacity, produced in 2017. In my left hand I have another drive, Western Digital. Western Digital, 12 terabyte capacity, produced 3 years later, 2020. Both drives looks similar. Despite of the fact this drive is Hitachi, this is Western Digital, both of them are related to the same architecture. If you pay attention on the reverse side of the drive, you will see that printed circuit boards are similar. And actually this is probably the easiest way how to recognize the drives, because this drive which has the special label on the PCB usually is Hitachi. Yeah, as you probably remember, on Hitachi IBM ARM, Hitachi IBM drives, we always have same kind of the label. On the Western Digital, native Western Digital drives, the number is printed on the board, and actually this number is different if we compare with the number on these drives. So also I can say that both types of interfaces are supported, not only SATA but SAS drives also, and there is a small difference between using the PC-3000 UDMA or Express or PC-3000 Portable or Portable 3 for diagnostic. So right here I have PC-3000 Portable 3, and for example, I want to connect my drive to the port number 0 for diagnostic. What will happen after that? I'm using the at first HGST drive and connecting it through the SATA cables. When you work with CCB drives, you don't need to use terminal connection at all. And I'm sharing my screen with you and starting Portable Pro. Double click on it, portable port number 0, and power on. Drive is starting to spin, it's busy state, so we're ready for the DRD DSC registers to begin. And right now I can press auto detection. My drive is detected like HGST CCB. You can see that this new utility is related to the Hitachi group. Double click on it and I have the message that you need to use special adapter for this drive. So actually that's what I wanted to say. When you work with UDMA or Express, you don't need to have any adapter. You can connect the drives with the cables without anything else. But if you have Portable 3, Portable Pro, you need to have this adapter. This adapter is called HGST CCB, and soon it will be possible to buy it. Yeah, and why it happens? Because there is a difference between the size of commands on our tools and the drives by itself. So what if you continue work without the adapter? Is it dangerous or not? Of course, it's not dangerous. If you press OK here, you will just quit from the utility, and that's all. You will not harm the drive, you will not destroy anything, you will just not be able to start the diagnostic. So for the Portable 3 and Portable Pro, it's necessary to use the adapter. How to use it? First of all, you need to connect this side as usually to the device and another side to the cables and to the drive. Usually these drives need a little bit more time for getting ready because they are higher capacity and heads need more time for recalibration and uploading the software. Now it's okay, I can double click here and as you see my drive is started. In this additional window, you can see a few supported families right now. Of course, this list in future will be increased. And if, for example, your drive is not in this list, you can use a group of common CCB. Common CCB means common code base. Common code base. So these drives may be different, may have Western Digital HGST label, different configurations are possible, but both of them are same architecture. That is the meaning of this name. Yeah. So on the right side also you can manage the power, you can start the motor and do additional operations with the drive. Right now I need just press utility start and drive will be started without any problems. You can see the huge log about initialization here and how actually to understand if drive is okay or not okay. I recommend you to pay attention on the sense code, actually where to see the sense code. I clean the log right now, go to the utility status, press on the start unit and then HDD status. And on this part of the log, I can see that there are sense code here like zeros, so drive is in good conditions. And also in the second part of the log, I see like degradation reason, no error, and broken reason, also no errors. So for example, in real life, we have seen the drive which looks like security locked, like a password log, but actually the reason was related, main reason was related to the broken heads. So the special heads code may help you to recognize the real issue. What should I do when I start the utility? First of all, as usually, we recommend to perform the backup. So I create the profile folder for the backup, press OK, and what actually I need to save here. As you see, there are several types of service area objects, ROM modules and log dumps. Log dumps is one new kind of objects. They are also important like modules also, so we recommend to save all of them. As you can see, there is no any ability to select the copy here. That's why configuration should be used by default for all drives. Yeah, and actually backup will be finished soon. If your drive is in good physical conditions, all these objects will be saved quite fast. If something is not okay, you will see the error messages during the backup, of course. But how to check the drive, how to check the service area? The same way as we did before, we can go Tools, Utility Extensions, Modules table. When you open Modules table, you will see the huge list of objects with different parameters like ID, like size, and some other things. Unfortunately, we have no importance group like we have for Western Digital, for example. That's why I recommend to pay special attention on description to understand if drive is important or not. As you see, some objects may be yellow color with warning because they may don't use checksum. Most of the modules use checksum, but some modules are not using checksum. If you open any module, we have the special ability to check and to fix the checksum if necessary. That's why, for example, if you rewrite some modules from the donor, it's necessary to fix the checksum here. Actually, I can say that it's a good idea that if you have the donor drive in good conditions, to compare the parts of the service area. It may help you to recognize if some objects are in good conditions or not, and if necessary to rewrite them. To rewrite, it's recommended to pay attention not only on the module of the drive, but also on the firmware version. Better to have same firmware version for rewriting. Yeah? Modules could be read and written through these options. Actually, there is ability to perform a translator recalculation. As you know, for many different storage devices, translator is one of the most important parts of the firmware. And on these drives, translator could be corrupted because of, for example, power outage. Due to power outage, translator could be broken and it's necessary to recalculate it. Of course, before we recommend to perform the backup and then you can try to use the recalculation option. But pay attention that recalculation is a permanent operation, so it's necessary to be sure that heads are in good conditions and they are able to write. Unfortunately, right now, there is no ability to perform head test in the utility. That's why I can recommend you, for example, to find some modules, small size, like this one, generic module, could be used for the manual test. You can change some bytes here, then write it and check if heads are able to write and then perform recalculation after. Of course, some other modules could be damaged too, like for example, one of module is the event dump log, which also can be damaged due to power problems, and this module could be taken from the donor drive. What else? What else? If I go utility extensions, I can see also the log dumps. The log dumps. Yeah, here how log dumps looks like. In future, our developers will add some special editors to work with them and to use this information for recognizing the problem. Yeah, and you will be able not only check the modules table, but also use the log dumps for your work. What else? In the utility right now, we have ability to deal with the heads map. So if you suppose that one of heads is not in good conditions, you may use the heads map editing to spare the heads, yeah, as we did previously for many cases. I hope you remember it. Of course, in data extractor, if I create the task, it's possible to build heads map and to check the heads one by one. That is the most efficient way to understand the real condition of the heads. So just in case I'm creating the data extractor task, and to prove that heads map is working, I can see that heads map is in progress right now. So if I stop it, you will see that how many heads we have, and if necessary, you can check them one by one. Then, if I press on settings group, I can say that right now there is no any active utility actions for this utility, but of course in future it will be added. We will collect more information about this drive and will add more solution, of course. What else? I can say that there are some specific cases in our practice which are related to the special kind of lock, not security lock, not ATA password or something like that, but PSID lock. This drive which I have tested has no any lock, but let's try to check another one. I'm quitting from data extractor and quitting from here. So I will disconnect my drive and will plug this. Drive is Western Digital label. Pay attention. On this drive we have the QR code on the label, and actually this QR code could be used for unlocking, should be used for unlocking procedure. You can use special application, any application for it, and scan it, and you will get the code. Actually, the code usually is located here also. You can type it manually, and that's it. It will help you to unlock the drive. So how it works, I will demonstrate on practice. I'm plugging the drive to the portable and sharing the screen. Power on. Drive is starting to spin, it's busy state. Of course, these drives may take a little bit more time to get ready. Sometimes it could be around 30 seconds, for example. It's normal for them, so I need wait a little bit. When drive is ready, I can press run, and for example, what will happen if I just start the drive like usually, pressing the utility start from here. I will see that drive is the technological mode is not accessed because of special PCID lock. It means that I need to unlock the drive somehow. Right now I cannot do backup or anything else. There is no any available actions. So I have to quit from here and start again. Port number 0. And start utility. Here on the right side, we have ability to enable PCID unlock option, and the utility will ask us to create the profile folder, because inside of this profile, it will add the small text document where the code will be put. So it's necessary only once use this code, and after that you will be able to work with the drive without any problems. So I have the code here, so I need just to copy and paste, press OK, and drive will be unlocked right now with the full service area access. Right now I can do the backup and everything works well. Actually, this is very simple way to unlock this drive, so you can use it and get access to the service area, to the user area after that. So actually, what else? One simple advice which I can give you when, for example, your drive is freezing or hanging after the start, it may be related to the timeout, because in the utility the standard timeout may not be enough actually for the this kind of drive, because by default it's like this, and that is what you should use. I prefer to increase it 10 times. For example, you can use this option to use it for HGST CCB architecture, yeah, because this drive may need more timeout. It will help to bypass the freeze, to bypass the busy state when drive is not starting well after power on, and the utility gets some stuck. Yeah, actually, of course, this utility is not the single thing which we added to the new release. If you are interested, I hope you will find a lot of more information about different updates, of course, and also you're welcome to share your experience with CCB drives, and if you need our help, we always glad to do it. So, of course, you also helping us to improve our software, and thank you very much for your attention, and that's all for me. See you next time. Bye bye.
All right, so thank you very much, Sergey. And now we are ready to talk about the SSDs. As I already mentioned, we can work with some new controllers, and actually ASLab developers were able to add a few new Silicon Motion and Phison controllers. And if you look at this slide, you will see that at this moment, actually almost all existing Silicon Motion and Phison controllers have been already added into support list, especially when we're talking about the SATA drives and of course NVMe, because yeah, there are some absolutely new modifications that were releases just a couple of months before, and these controllers are very new. They are based on PCI Express 5.0 technology. They are still under researching, but of course they're pretty rare right now, because actually we didn't get any faulty controller like Silicon Motion PCI Express 5.0 right now. And we are planning that during the next few months, new controllers will also be added, and we will extend the support list of our SSDs. But right now, let me show you which new controllers ASLab developers add into PC-3000 software. And first of all, please let me share my screen and let me launch the SATA port, SATA Utility. So now let's talk about the new features for SATA controllers. Actually, the list of supported controllers will remain to be the same, but ASLab developers add a lot of new features for already presented controllers, like very famous Silicon Motion 2258 and 59XT, because right now we get much more loaders than before. ASAP developers also add the possibility to work with Samsung chips, because previously we faced some problems when we are dealing with them. And also they were implemented the new feature to work with QLC memory chips, because again, previously, in case if you got the solid state drive, which is based on Silicon Motion 2258XT or 59XT, and there is some set of QLC memory, there could be some problems in loader uploading step. But right now, these utilities get more loaders, and I'm sure that if you will get one of these drive based on QLC or based on Samsung, please feel free to contact technical support. We will guide you what to do. Also, the Maxio Utility get a serious improvement for amaze HGST. And actually right now almost all SSDs which are based on this controller are supported. And we got a lot of positive requests from our technical support, because we got a lot of requests for this controller recovery. And with the new version 7.7, we got a really huge improvement in success rate with this controller, because the non-configuration set was improved, the translator building algorithm has been improved, and right now we can work with a lot of different modifications of SSDs which are using various combination of this controller and NAND memory chips. So we can work with Intel chips, with Micron chips, we can work also with Unix chips, and some other brands like SanDisk, like Toshiba, like Samsung. They are also partially supported, but all depends on the case. Most of the SSDs which are using this controller, they are using Intel or Micron memory chip. And if you get one of these combination of controller and Intel Micron chip, feel free to contact ASAP technical support, we will guide you. And of course, let's talk about the NVMe drives. What's new in NVMe utility? And as I mentioned before, for Silicon Motion, we got two new controllers. It's Silicon Motion 2267XT and SM2269XT, but actually this controller have been added before in previous software, but now it gets some improvements and got some new loaders. So if you will meet some new combination of controller and non-memory chip, I'm sure you can try to use this utility, this universal utility for this controller to reach the data. And first drive that we are going to show you will be Silicon Motion 2267XT. Actually, this is a pretty small drive, which based on this controller, it's Kingston NV2 model. This is PCI Express 4 SSD, and right now we will try to connect this drive to our adapter and read information from passport ID. So let's start the power supply and launch universal utility. So here we can see that drive contains not a complete passport, because it's staying in safe mode, and it means that internal firmware or internal translator has been corrupted. And again, as always, we need to follow by Silicon Motion controller vendor, select the target controller name, and jump into utility. So as you can see, for now, we're going to select the Kingston NV2 model of this SSD. But at this moment, there are a lot of modifications of solid state drives which are using this controller. So don't care about the name of utility, because in theory, any Silicon Motion 2267XT drive will be fully supported with this utility. And we got here information that this SSD is based on Toshiba memory chip. Let's load the loader for these chips, and we got some extended information about the drive firmware, number of memory chips, chip capacity. Everything seems to be fine. And of course, we shouldn't forget about the chip test, because the sum of capacity of our memory chips should be equal to the SSD capacity in the drive label. So if I will calc 69804 on 8, I will get something around 500 gigabyte of capacity, which exactly the same, which is written on the drive label. Plus, we got here some extended capacity for relocated sectors, for ECC correction, for firmware storing, and so on. But in general, all chips are fine, and we are going to build the new translator. And let's start it. Of course, we need to make the new profile where we will save the resources from this SSD, including the new custom translator. And the whole process should take some time, so we will wait before the process will be completed. So you can see that this is Kingston drive with 500 gigabyte capacity. Let's make a new profile, save the resources, and let's build the translator. So let's wait and we'll continue when the translator will be over. All right, so process is almost done. And as I usually mentioned before, the speed of translator creation depends on the drive capacity, drive condition, and for this model, we can see that it takes around 20 minutes to build the translator. So let's check the data extractor. Do we have any internal data here or not? Let's see. So let's make a new test task. You can see here that the covered drive contains a complete LBA, and we can make a copy. So let's check. And here is our data. We can see that the root structure become opened. Files are available. We can open them. And drive condition isn't so bad. So yeah, we get it. Actually, the same story is about the new Phison 2221 controller, because this controller also been added into support list, and we are able to work with this controller as well. This is a pretty fast PCI Express 4.0 controller, which contains a wide support of different internal NAND memory chips, and in current update 7.7, it became possible to work with this controller and with these SSDs based on this CPU as well. So again, if you will get any questions, please contact technical support department and we will guide you. Okay, let's continue with our next topic, and this topic will be about the formatted Phison-based SSDs. Actually, you know that formatting of SSD makes the data be zero field, and unfortunately, after the drive formatting, it's not possible to find any useful data on SSD because the data become hidden by zeros, and it become filled by zeros because the new translator after formatting hide the data, and it's not possible to see the real information which was recorded on the SSD before. And the new update will provide us an opportunity to work with formatted SSDs based on Phison controller and roll back the old translator versions, because with the old versions of the translator it become possible to roll back the changes and see the content even after the drive being formatted. And we got here a pretty interesting small silicon power SP55 drive based on Phison controller, and I already plugged it to PC-3000 portable. So let's take a look how the formatted drive will look like. We can see that the drive is fully working. If I will try to edit the LBA, everything looks fine. But as soon as I will try to launch the data extractor and will see the content inside the drive, I will see that unfortunately this drive after formatting will contain just a few folders and a few metadata, the new metadata which appear on the drive after formatting. So you can see that there is no user data which was previously recorded at this SSD. So if I will launch the raw recovery to find some file headers, I would be able to find only metadata files and file system files of new drive, of new formatted drive, but not the old one, because there were a lot of pictures, there were a lot of folders, a lot of office files, but nothing was found after raw recovery. So what we need to do in this case? Of course, we need to roll back the translator, and for doing this, we should use the Phison utility for current controller. And our controller is Phison-3111. First of all, I need to use tweezers to short the drive into safe mode, to block access to the original firmware, and only after that I can launch the utility and build the new translator, the new custom translator, which will include the previous copies of the translator tables. And you can see that right now we will try to initialize the drive with the loader for SanDisk chips. Let's wait. And actually this utility version get a pretty huge update, because our ASLab developers who working with Phison utility, they have to completely redo the translator building algorithm, because previously it take into account only the latest version of translator tables to keep the possibility to get only the latest files and the latest folders which were recorded at the SSD, to provide the customer the best quality result before the drive become corrupted. But now we need to take into account also an old versions of the translator tables, because they contains data, because the latest translator table contains only zeros. So we need to roll back to the translator, get the information about previously allocated data and use it. That's why I'm going to start the translator building algorithm. And of course, there could be some additional troubles, because we never know how much time passed since the time when the drive has been formatted. And did customer write any new data on the SSD, or he did not do that before? And I can say that this drive stays after formatting for a few days powered on. And some data could be trimmed here. So we will try to get the data, but most likely that the final result will not be perfect. Because again, trim command may erase the data in the background. Of course, even trimmed drive will be possible to recover information, not probably all of it, but some of the data. So we will see which result we will get in our case. But again, every case is unique and individual. That's why we recommend you to ask your questions in TS department, because from our side, we will try our best, but from your side, from customer side, we need to get as many information about formatted drive as possible, including the information about formatting, about how much time passed since the drive been formatted, what exactly did customer did with the drive, did he write anything on the SSD, or probably did he try to use some third-party tools to scan the drive and find the information inside of raw recovery, for example, because when the drive is powered on, trim might start working. Anyway, in our practice, we can say that we did some deep research, and we find that even the oldest data, which was deleted probably 6 months ago, could be still presented on the SSD, and it's still possible to find the previous versions of the files, previous data which was recorded before the drive been formatted, and we can successfully recover data even if a lot of time passed since the formatting or file deleting. But again, every single case is unique, so we need to be very attentively when we are working with such cases and collect as many information as we could. So the translator building algorithm already over. You can see that in compare with previous task, translator building algorithm for this SSD takes just 3 minutes, while for Silicon Motion NVMe it takes almost 20 minutes. So let's wait a bit. Alright, so translator building complete, and we can see that the file of translator has been automatically saved into the drive profile folder. So please make sure that your drive C, where the profile folder has been set automatically, contains enough space, because sometimes translator may take a few gigabytes. Alright, so let's jump into data extractor and make a new task. And we're going to use the data copy. Let's choose our data extractor storage for temporary data storing. And after that, the same as for Silicon Motion SSDs. To see the data, it's not just enough to launch raw recovery on the main partition, because again, the data will be still missed here. We need to add the virtual drive with access by physics. And when we will add it, again, it will be still not enough to see the data, because we need to add the virtual drive. So let me do that. We add the virtual drive to read the data by PBA, by physical access. And still no data, but it become possible to edit this result. And now we can play with the versions of root, with the version of boot sector, master boot, and so on. And for example, we can roll back to the older versions of boot, a root folder, and master boot. Refresh the result. And of course, after that, we need to launch the selection versions for metadata. This is automatical process that will take into account all previously read copies of the translator. And we will scan the MFT record, we will scan all user data which was stored here before the formatting, and we'll try to generate the virtual file system. Of course, some areas contains a lot of bad bytes, bad sectors, because we are reading an old data, and due to the NAND memory chip bad quality, due to the self-discharging, some data could be damaged, unfortunately. But again, what we need to do, if we still don't see any files, we can launch a simple data analysis and scan MFT. So let's do that. And after the scan, we'll see our missed data. Of course, if I will try to open some wallpapers, for example, some wallpaper files, we can see that for the same files we get a few copies which were storing on the drive before. And that's great, because again, if I will set the headers control, I will see that, for example, this file was missed, but I can set the version of this file and recover it manually like this. And after that, more files will become opened, and more files become located into the correct position. And here is one by one, we can fix almost every single files on this SSD. And let's try to open some of them. like for example this file, and we can see that this file is in a great shape. We can open it and it's fine. But some files, unfortunately, like for example, if we'll choose this file, we'll try to open it, files may contain some bit errors. And these errors appear due to the bad quality of the NAND. And also they could appear because the trim command, trim already may erase some parts of this file. And if I will try to open it, yes, it's fine. But for some other pictures and some other files, situation might be not so good as this one. For example, if I will try to open this, yeah, this fine. Maybe let's try this. Yeah, you can see that unfortunately contains some bad sectors and the quality isn't good. But again, we can try to play with some file versions, and probably if we will reopen it, everything would be fine. And again, this unique method allows you to recover deleted data, formatted SSDs, and actually in general it doesn't make sense how much time passed since the drive was formatted or data been deleted, because in most of the cases you can get a very good result. Just need to do some manual work, assign some versions for target files, and final recovery result will be very promising. Because again, for this case I am starting to set the file versions manually, and you can see that for every single file where I set the version, condition of the file become pretty good. This is how we can recover data from formatted Phison-based SSDs. The same steps we need to apply for NVMe drives in case of they are formatted, or for any other Phison-based SATA SSDs. Alright guys, so I hope you really enjoy this video, because my colleague Sergey already described you some interesting information about the new Hitachi CCB Utility that appear in current update, and you already saw what's new appear in SSD utilities for SATA and NVMe SSDs. And again, in case of any questions, our technical support staff is waiting you in our technical support portal. So, see you next time. Bye.